in this video today, I am going to go over the steps or the algorithm for dividing by a 2-digit divisor. Now, if you recall, we went over the basic algorithm for dividing by a single-digit divisor, which was, and many of you have used this in lower grades, a little acronym. Does McDonald's sell cheeseburger recipes? And that's a good way to remember the steps, because instead, of course, of using does McDonald's sell cheeseburger recipes, that helps you to remember the first letter of the steps that you do in order to divide. So the first step would be to divide, then you multiply, next subtract, after that compare, meaning comparing the remainder to the divisor. The B stands for bring down, and the R either stands for repeat or remainder. It depends on what happens in the step before. If you bring down a digit, then you have to repeat. Now, in class, I've told you many times that really the first step you need to do is put a dot above the digit in the dividend where the first answer goes. So, these are all the same steps for dividing by a double digit or a 2-digit divisor with just a few extra little modifications. All right, so let's begin. So the first step, I need to find where the first answer goes. 30 will not go into 7, but 30 will go into 79. So my first answer is going to go above the 9. Now, in order to divide, when you have a 2-digit divisor, you are going to have to estimate how many times that goes into the dividend that is showing. The easiest way to do this, there's more than one way that you can do this, but the easiest way you can do it is by looking at the front end digits of each number. And I'm going to underline those. So to get an estimate, I would ask myself, how many times does 3 divide into 7? Well, 3 goes into 7 2 times. There is my estimate. And that goes where we said the first answer goes. So now I have divided. The next step, I am going to multiply. I am multiplying 2 times 30, the whole entire divisor. Now, some students have trouble multiplying diagonally like this, although it would still be just 2 times 0 is 0, 2 times 3 is 6. If you have trouble doing that, though, it's perfectly fine to go off to the side or on a scratch sheet of paper and actually multiply it. So we have 60. Now, I can subtract 60 from 79, so far I'm safe. So now I'm going to subtract. That's our next step in the algorithm. 9 minus 0 is 9. 7 minus 6 is 1. Now I'm going to compare to see if the remainder is less than the divisor, because remember, it always has to be smaller. And it is. The next step would be bring down, but since there is no other digit to bring down, that means we have a remainder. So the answer would be 2 with the remainder of 19. Now let's look at another problem. On this problem, I've added one more little step of difficulty to what we're doing. So first step, find where the first answer is going to be placed. 34 does not go into 6, but 34 will go into 67, so the dot goes above the 7. Now, I'm going to estimate how many times 34 goes into 67 by looking at the front end digits. 3 goes into 6 2 times, so that is my estimate. But now you're going to see something different happen in this problem. So now the next step is I'm going to multiply 2 times 34. And remember, if you need to do that on scratch paper, that's fine. 2 times 4 is 8. 2 times 3 is 6. So you get 68. But we have a problem. You cannot subtract 68 from 67. Our estimate was too big. Many times in division, this will occur. Even though 3 does go into 6 2 times, you have to remember this is just an estimate. So because 2 is too big, we're going to have to erase it and try the next smaller number. Well, if 2 was too large, then obviously we're going to have to use 1. Now, when we multiply 1 times 34, hopefully you don't have to do that off to the side. 1 times 34 is 34. Now this time we can subtract 34 from 67. So subtract 7 minus 4 is 3. 6 minus 3 is 3. Compare. The remainder is less than the divisor. We would bring down the next digit, but there are no other digits to bring down, so that means this is the remainder. 1 with a remainder of 33. The main point I want to make on this problem is that when you get an estimate, that's exactly what it is. It is just an estimate. Sometimes your first estimate will work out perfectly, and other times you're going to have to alter or change it until you can find one that will work. Let's look at another problem. So I'm going to add another small level of difficulty, and if you notice this time I'm using a dividend that has 3 digits in it. But don't let the number of digits in the problem freak you out. You go through the exact same steps. Okay, find where the first answer goes. 45 will not go into 1. Scoot my blinder over. 45 does not go into 18, but 45 will go into 189. So my first answer has to go above the 9. Now this time, in order to estimate, I said before or previously, you always look at the front end digits. But this is another problem where you're going to have to do just something slightly different. I look at the 4 and the 1, but the problem is 4 will not even go into 1. So if this front end digit in the divisor doesn't go into the first one on the dividend, look at the first 2. So 4 won't go into 1, but 4 will go into 18 about 3 times. So 3 is my estimate. Now I'm going to multiply 3 times 45. 3 times 5 is 15. Carry the 1. 3 times 4 is 12. Plus 1 is 13. So 135. I will be able to subtract that from 189. Next step is to subtract. 9 minus 5 is 4. 8 minus 3 is 5. And 1 minus 1 is 0. Now, when I get to the next step, though, I'm supposed to compare. My remainder has to be smaller than the divisor. Uh-oh, it's not. So I've made a mistake somewhere. Well, obviously, I think I've made a mistake up here with the 3. Now, I've noticed in class several of you tend to do this, and you forget this last step of comparing. One of the main reasons is because maybe you don't have a strong command of your multiplication facts. 4 does not go into 18 only 3 times. So I need to back up and try this again. Now, I did that on purpose just to show you that that is a careless mistake that many of you unfortunately do make. 4 goes into 18, not 3 times. 4 times 3 is 12, but we can get closer. 4 times 4 is 16. That is the closest you can get. Now, 5 would be too much because 4 times 5 is 20. Okay, now we're going to multiply. 4 times 45. 4 times 5 is 20. Carry the 2. 4 times 4 is 16 plus 2 is 18. 180. I can subtract 180 from 189, so I'm going to subtract. I get 9. Now, that really important step, compare. Now my remainder is less than my divisor, so I'm safe. There are no other digits to bring down, so the answer is 4 with the remainder of 9. Now on this problem 2, I'm going to use this basic problem though to kind of show you the next slightly more difficult or level of difficulty in this problem. Instead of 189, let's make this a 4-digit divisor. Let's make this 1,897. Once again, don't let that freak you out. Go through the same steps. Now I'm going to go through this just a little bit faster. 45 does not go into 1. 45 will not go into 18. But 45 will go into 189. Dot goes above the 9. Front end digits to estimate. 4 won't go into 1, but it does go into 18 4 times. And now we're going to multiply 45 times 4. Now I'm just going to go ahead and do this over here in the problem, although remember, perfectly fine to do it off to the side. 4 times 5 is 20. Put down the 0, carry the 2. 4 times 4 is 16, plus 2 is 18. I can subtract 180 from 189. So subtract, you get a remainder of 9. Now compare. 9 is less than 45. The next step is to bring down the next digit. This time we do have a next digit to bring down. So once we do that, then we repeat and go back to the first step of divide. Now I am going to rewrite my divisor down here beside my new dividend. So 45. When you repeat, you are starting over, going back through the same process. So I need to estimate how many times 45 goes into 97 by looking at my front end digits. So how many times will 4 go into 9? Well, 4 times 2 is 8, and that's as close to 9 as we can get. So we're going to estimate that it goes 2 times. Now keep in mind, the 2 may be the correct estimate, or we might need to alter it a little bit. So we're going to multiply 2 times 45. So 2 times 45 is 90. Well, our estimate worked because I can subtract 90 from 97. So I subtract, I get 7. Now compare. 7 is less than 45. There are no other digits to bring down, so it is 42 with the remainder of 7. Now let's look at one more problem. And for many students, this type of division problem sometimes gives them the most problems altogether in division. However, it doesn't have to. So, find where the first answer goes. 19 will not go into 1. 19 will not go into 18. But 19 will go into 186. First answer goes above the 6. Now, when we estimate by looking at the front end digits, something kind of weird happens. 1 does go into 1. It goes in 1 time. But here is where you have to be aware of your problem and use just a little bit of common sense. Common sense should tell you that 19 is going to go into 186 way more than just one time. So in this case, you want to go on the opposite end of the spectrum. Meaning, instead of starting with 1, you want to go and start with the highest single-digit number that you can. Well, the highest single-digit number there is a 9. So we're going to start with 9. And trust me, by doing this, you are going to save yourself, in most cases, a lot of wasted time and wasted effort. Now keep in mind, this may be a good estimate or we may have to change it. Okay, so we're going to multiply 9 times 19. 9 times 9 is 81. Carry the 8. That's 9 plus 8 is 17. 171. 171. Well, look, I can subtract 171 from 186, so my estimate of 9 was right on the mark. Now just imagine what had happened if you had tried 1. 1 times 19 is 19. Subtract. You would have gotten a really large remainder that was bigger than 19. You would have had to have erased all that work and then tried 2. Erased it all. Tried 3. You would have gone through 8 multiplication problems that did not work. So this saves you a lot of time. Okay, so back to our problem. We just multiplied, now we subtract. 6 minus 1 is 5. Now 8 minus 7 is 1, and of course 1 from 1 is 0. Compare, 15 is less than 19. There's no other digits to bring down, so the answer is 9 with a remainder of 15. Now I am going to show you just one more problem. Let's do the problem 1,743 divided by 19. No, sorry, let's not make that 19. I think I just used 19 a moment ago. Let's use 18. Okay, 18 will not go into 1. 18 will not divide into 17. 18 will divide into 174. I'm going to estimate by looking at my front end digits. 1 will go into 1 one time. But common sense tells me there are many more 18s in 174 than just 1. So instead of 1, I want to find a much bigger single-digit number, so I am going to try 9. Okay, I'm going to multiply now 18 times 9, and that gives us 162. That's going to work because I can subtract 162 from 164. So subtract, 4 minus 2 is 2, 7 minus 6 is 1, 1 from 1 is 0. Compare, the remainder is less than the divisor. Next step, bring down the next digit, and then repeat. Rewrite my divisor 18. And then I start again. So I'm going to estimate by front end digits. 1 into 1 only goes one time, but 18 is going to go into 123 way more than one time. So I would try 9. Now in this case, I'm not going to have to go over to the side and multiply 18 times 9 again because, see, I already did that on the first step. So I know that the answer is 162. So if I put 162 here, we've got a problem because I cannot subtract 162 from 123. Therefore, my estimate of 9 for this step was too large. So I'm going to have to erase it. And instead of 9, I'm only going to go down by one number and try 8. So now I'm going to multiply 8 times 18. 8 times 8 is 64. Carry the 6. That's 8 plus 6 is 14. 144. Well, once again, my estimate was too large. I cannot subtract 144 from 123. So get our trusty eraser, going to erase it again, and I'm going to go down to the next smallest digit, which will be 7. Now, don't be discouraged because this is what happens in division. Many times it's take a good educated guess or estimate, try it out, and if it doesn't work, try the next one. Okay, multiply 7 times 18. There's 56, carry the 5. 7 times 1 is 7, plus 5 is 12. That's 126. Well, look at that. Yet again, it's still too large. I can't take 126 from 123, but look how close I am. I bet that the next lower number of 6 is going to work for me. So I'm going to erase it, and now I'm going to try 6. 6 times 18. So 6 times 8 is 48. Put down the 8, carry the 4. 6 times 1 is 6, plus 4 is 10, get 108. Well, finally, I can subtract 108 from 123. I'm going to have to borrow and rename. So 13 minus 8 is, right, 5. 1 minus 0 is 1, and 1 from 1 is 0. 15 is less than 18. There are no other digits to bring down, so the answer is 96 with the remainder of 15. Please watch this video as many times as you need to, and as I've said over and over again, you've got to practice these to get better at them. Okay, good luck.